have to catch the penguin. There's only one person that can help us now. The Riddler.
Riddler, how can we catch the penguin?
Well, Batman, I have a series of calculus problems for you to solve. And if you do that, then you may be able to find the penguin.
So, in order for us to get up the hill, we need to find its slope. And what do we know about basic slope? Well, it's rise over run, y over x, or in this case, dy over dx, because it's a vector which has two components to slope. Luckily for us, these equations are given, so we write dy over dt and dx over dt, which when simplified is just dy over dx, and then we evaluate this at t equals 4 seconds. Our trusty Bat computer is able to do the rest, and if you look down below you can see the basic calculations, leaving us with an answer rounded to 3 decimal places of 0.701.
So to cross the hill and find the penguin, right here, we're going to need to find our speed at time t equals 4 as we are going up the hill to make sure that we have enough speed. So to find our speed, we're going to take the square root of dx dt squared plus dy dt squared, and then we're going to evaluate that at time t equals 4. We plug that into the Bat computer, we get 5.035 in no units since we aren't given any. Now to find the acceleration as we are going up the hill, we are going to take the derivative of dx dt, so we would get d squared x dt squared. And then we're going to evaluate that at t equals 4. And then we're going to take the second derivative for dy dt squared and also evaluate that at t equals 4. So we plug that into the Bat computer again, and we write that in acceleration vector notation. So we get 0.970 and 0.444.
Okay, so now we need to find the y-coordinate of where the penguin is heading. It's very important. So in order to do this, we look at the problem, and hey, we have a given information that we need. But let's start with the problem. So we want to find the position of it at t equals 6 seconds. So we do y at 6 seconds, and we need to set up an equation. So we need to say the final, which is what we're finding, equals the initial, which, we have a point at t equals 4, so we're going to use that. So we're going to use the position at 4 seconds plus, and we need to integrate our velocity, which is dy dt, and that will get us the position. So we integrate that. So dy dt, we do that dt, and we do that from t equals 4 seconds to 6 seconds. Now, once we do this, how do we find y of 4? Well, if we look up top, we have the particle's position at time equals 4. So if we go to the y-coordinate, it's 5. So that's going to equal 5 plus the integral of 4 times 6 of dy dt dt. If we're finding this part, all we have to do is plug it in to our trusty Bat computer, which you can see right here, And this is going to get us a final answer of 11.571, which is the y-coordinate of the penguin.
To locate the penguin, we need to find the total distance he has traveled so far. You may think that this is incredibly difficult, but given the y-coordinate and the distance that we're about to find, we will be able to catch up to the penguin pretty easily. So how do we do this? We know that the basic speed formula is the square root of dx dt squared plus dy dt squared. All we need to do now is find the distance. To find the distance is to integrate over the interval of 4 to 6 seconds. This makes sense because the integral of the separate velocities will give us a position, which will give us distance. Now if we plug this into the back computer as so and let it calculate, we will get a final answer rounded to 3 decimal places of 12.136.
Now, lucky for us, in order to find the penguin, the Riddler has actually hidden the different data points in the problems he has given us. So, I'm pretty sure that there are 9 possible points of data we have to input into the back computer in order to find the penguin. So, the first one, I'm almost positive, is found within part A. Now, if we look within part A, I believe that the only point we will need is literally everything we have shown. In the end, it's just going to come down to your final answer, which you get, which is the 0.701. And I know that's not a lot, but it's all for nothing, and let's hope we did it right. Now, if we go to the second problem, this is a big one. It's actually going to be 3 different data points we need to plug into the back computer. One of these data points comes down to the acceleration. Now, that's just going to be our final answer, which we found right here, the 0.970 and the 0.444. 2 of the points are actually going to come from the speed. So one of them is just going to be the basic speed equation, and the other point is just our final answer, which is right there. Now, if we go to part C, this is also going to be 3 points of data input into the back computer. One of the points is going to be used for using the initial value, which is the y of 4. The other point is going to be for the actual integral, which is right there. And the final point, obviously, the final answer, which we have calculated. The last data point we need to locate the penguin is going to come from this problem. There are actually 2 points. One of them, again, the distance formula, which we have right here, or our integral, and the other one is just our final answer. Now, if we add up all those separate data points, again, it's 9 points, and hopefully, once we plug it in, it will be enough to find the penguin.
Hey, there's the penguin! Hey! We finally got you, penguin! You're going to Arkham.
Ahaha, I'm back.